Hi everyone. This is the final part of the classification videos in the machine learning playlist. So till now we have been discussing around the binary classification, which distinguish between two classes. In the case of multi-class classifier, which is also called multi-nominal classifier, can distinguish between the more than two classes. And there are few classifiers are available like logistic regression, random forest classifier, and Gaussian NB. So these are capable of handling the multi-class natively. Other are strictly binary classifiers, for example, the SGDC classifier and SVC. So they can only do the binary classification. For the multi-class classification, it's one way is to create a system that can classify the digit image of 10 classes from 0 to 9, and to train the 10 binary classifiers, and each is like 0 detector, 1 detector, 2 detector, and so on. Then when you want to classify an image, you get the decision score for each classifier for the image, and you can select the class whose classifier input the highest score. So this is called one versus the rest strategy, right? And sometimes the one versus all. So in this uh, and there is another strategy is to train a binary class for each pair of digit. One distinguish 0 and 1, and the another distinguish 0 and 2s. And this is called the one versus one strategy. And if there are n classes, you need to train n multiply n minus 1 divided by 2 classifier. For the dataset which we are using MNIST problem, this means we training 45 binary classifiers. When you want to classify an image, you have to run the image through all 45 classifiers and see which class win the most well. The main advantage of one versus one is that each classifier only need to be trained only the part of training set containing two class that it must be distinguished. So some algorithms scale poorly with the size of the training set, and for this algorithm, one versus one is preferable because it is faster to train many classifiers on a smaller training, and for most the binary classification algorithms, one versus rest is preferred. So let's try with this support vector machine SVM, and that's what we have loaded here, SVC classifier, and we are going to train only the 2000 data sets, and that for that I think that would be easy and fast. So loaded the SVC, fit the model on X train and Y train, and predicting, so it predictive 5 with the correct, right? The first value is 5 and that has been predicted correctly. We can use the decision method, and you will see it will return 10 score per instance. So if I check for that, you can see there are 10 scores, and 8 3 or 9 3 is the highest one. 0 1 2 3 4 5. So it has checked for each instances 0 to 9, and the 9.3 is the highest. That's why it has written 5. And you can check the classes also, which will give you like all the classes 0 to 9 SVC classifier, right? And if we make the let's check the one versus rest strategy. And in this, by training with first 2000 records in both train and X train and Y train, and if you make the prediction, it is giving the correct value of 5 here. So training an SGDC classifier on multi-class data set and using to make prediction is just an easy part of it, right? I can use the same thing here, and what it will do, instead of previously we have used for the estimator detector 5, now it is for all. And let's check with what the SGDC will do. So it has predicted 3 here, like that's wrong because the value is supposed to be 5, and that's why the SCD is not performing well, and it's not very confident. The prediction over almost all these scores are very negative. while the class A has the positive one. That's why it has given this value, this predicted this sum digit, which was 5 as 3, which is wrong. Now let's move to the next part of it, error analysis. So in the error analysis, uh, if what we are going to do first, we need to make a prediction using the cross predict function, and we are to also going to display the confusion matrix. So in the previous we only did for the detector 5 for one, but in this case we have multiple detector size 0 to 9, so there will be multiple rows and columns in the confusion matrix, and the best way to is to display is confusion matrix display from prediction. So these are the predicted labels and these are the true labels, and what it will do, it will produce, so the main diagonal here, right, it is which these are the classified, means these are the numbers which have been classified correctly. And notice that the cell of the diagonal in the row 5, right, and the column 5 looks slightly same, right, means darker than the other. You see this one, and this is because there are fewer fives in the data set than the other digit. That's why it is important to normalize the confusion matrix by dividing each value by the total number of the images, and after doing that we can use the parameter called normal equals to true, and this is what you will have the normalized decision confusion matrix. And the next what we have is you can also change the value format to read it correctly, right? For example, the 36% in the row 7 column 9 does not mean that the 60 36% of the images of sevens were misclassified as 9, right? It means that 36% of the error that the model made for the image 7 were misclassification as 9. So in reality, only 3% of the images of sevens were misclassified as 9, as you can see in the diagram, right? And analyzing the confusion matrix often give you the insight into way to improve your classifier. And look at these plot. It seems your effort should be spent on reducing the false 8, right? For example, you could try gather more training data for the digit that looks like 8, and so that classifier can distinguish from them from the real 8. Now, until each instance has been used for just one class, and but in some cases you may want to classify to output multiple classes for each instance. Consider the face recognition classifier, what it should do if they recognize several people in the same picture. So it should attach one tag per person it recognizes. See, the classifier has been trained to recognize three faces A, B, C, and then the classifier in the shown pictures of A and C should output true, false, true. Meaning A is classified correctly, B is classified incorrectly, and C is classified as correctly. So, such as the example of the multi-label classification system. And here we can use name-enabled classifiers. In this case, we are classifying which is greater than 7, and also it should be the odd. And that's what we are doing here after fitting the uh, model, and we are predicting the same digit 5. So it is saying false, means it is not greater than, which is correct, greater than 7, and it is odd, which is true. So it is giving the correct results here. And if you check the F1 score, that is also really great, than the 97%. And if we use the classified chain, so then it is also giving this. So classified chain, it is what it will do. It will use two label for training and feeding each model the appropriate label depending upon their position in the chain, right? So for example, the larger digit 789 is twicely more likely to be odd, right? Because 7 and 9 values are odd here, but the classifier or the odd label does not know what the classifier or the large label predicted. So to solve this, it can be used using the chain. And when a model make a prediction, it uses the input feature plus all the prediction of the model comes that comes before in the chain. And that's what we are used for that. For the same purpose, we use the classified chain, and we are using SVC as the model. CV equals to 3 iteration, and after giving the it's giving the prediction 0 and 1. In the last, I would like to use the multi-output classification, and which is nothing but uh, checking of generalize the multi-label classification where each label can be multi-class. And to build, we have built one noise around one image, and in the next tab, what we are doing, we are reducing that noise and trying to predicting what the value looks like. So this is here in this set of a code is nothing but it's adding the noise, and in the training set, the original image was 7, the noisy image, and the last one is the cleaner image. So it is outputting the cleaner image. So this is nothing but the multi output character classification. So we have just to conclude this classification, uh, we have checked the multiple performance measures, the accuracy, the precision, recall, and the confusion matrix for one classification, the five detector, and for multi-classification, we have a confusion matrix with multiple classification. We have used the variety of classification models, and also we have seen the just to recap the multi-label and the error analysis, and also we have seen the multi-classification before. In the previous videos I've shown the only the one classifiers, and this is how the multi-classification works here. So this with this we conclude our video and the series on the classification. We'll continue to go more depth of each of these regression classification problems. Thank you.